Hello friends, in this video we are going to study system properties in terms of impulse response for an LTI system. Therefore, already this system is linear and time invariant, and now we are going to study the different properties and classify the system as static, dynamic, causal, non-causal, stable, unstable, invertible and non-invertible based on the impulse response of the system. So let's begin with the first property. The first property or classification is static, which is also called as memoryless, versus or dynamic, which is called as memory system. Now in this case we will be provided with the impulse response of the system. So in order to classify this system as static, we will be given with this system impulse response h of t, and if this h of t can be represented in terms of constant c into delta of t. This c is a constant value. If we can represent given impulse response in terms of a constant value multiplied by the impulse function, then such systems are said to be static system. Similarly, if we represent it in discrete form, it can be written as h of n equal to c into delta of n. And if this condition is not satisfied, the system is said to be dynamic. So for dynamic system, this h of t will not be equal to c into delta t. Similarly, h of n cannot be represented in terms of constant into delta n, which is impulse function. Now the second classification is causal and non-causal. So for a system to be classified as causal, the impulse response h of t should be equal to 0 for the condition t less than 0. Similarly, for discrete form, our h of n will be 0 for n less than 0. And for non-causal system, this condition will not be satisfied, and this h of t and h of n will exist on negative axis. So this is how we can identify whether the system is causal or non-causal. Now the third classification is stable and unstable. So for a system to be stable, again we need to check the condition for impulse response of the system, and this condition states that if we integrate the impulse response of the system from minus infinity to plus infinity, this should be finite. It means it should be less than infinity. So if we integrate the impulse response of the system and its value is finite, we get the system has to be a stable system. Similarly, for discrete notation, summation k equal to minus infinity to plus infinity, mod of h of k should be less than infinity. For unstable cases, this integration will become equal to infinity. If it becomes infinity, our system is unstable. Similarly, summation can be represented, the discrete system can be represented as integration minus infinity to plus infinity mod of h of n will be equal to infinity. So this system will be unstable. And the last classification is invertibility, that is invertible and non-invertible system. For system to be classified as invertible, there exists an inverse system which is represented by h inverse of t, and if you convolve this impulse response h of t with h inverse, this convolution should result into the impulse function. So if we have such kind of provision where the inverse of the impulse response is available, such systems are said to be invertible systems. Similarly, in discrete domain, h of n convolving with h inverse of n will give us delta of n. So for non-invertible system, there won't be any h inverse of t and h inverse of n doesn't exist. So in this way we can classify our system in terms of impulse response. So these four properties are to be obtained, and remember our system is already an LTI system, so it is linear time invariant system. We are going to classify this LTI system into these four classes provided the impulse response is available with us.